On your master's, and you had a lot of interesting equipment to work with.
As contrasted to what happened in the rest of my life, when you were at the U Physics department and you wanted something done, you went to the machine shop or you went to the electronics shop and you explained to them what needed to be done, and they asked who you worked for, and they did it.
Oh.
That's all the red tape there was.
Oh.
And so it was very easy to get parts and get things done. And even down to, I remember I discovered one of the fellows in the machine shop did woodworking too. And so we ordered a bookcase. And on the way back, I ran into a friend and mentioned we had ordered the bookcase, and he said, "I hope you have it right, because by the time you get back to your office, he'll have it cut out." And he'll be up there in an hour with it assembled.
About this equipment shop, John Harry Williams, who was a professor at the U, had worked at Los Alamos during World War II. He was very influential in the U of M physics department and insisted that the lab have adequate equipment and supplies for learning and experimentation.
Well, mass spectrometers were rather new instruments in those days, or rather high tech, and there were none made commercially. Most of the spectrometers were made in the physics building. The machine shop made all the vacuum equipment, and the electronics shop made all the electronics, which was designed for the machine you were working on. And part of the vacuum system in the intake manifolds and glass work was all made out of things by the glass shop in the basement. So the real guts of the thesis was to actually build a source which used the weak focusing and show that it worked, and how well it worked, and what kind of results you can expect to get out of it. And they weren't as good as they had been hoping, and it was rather took up a lot of space and was a little difficult to build. So it was an interesting exploration into what could be done, and we showed it could be done, but it just wasn't practical.
And you had to piece it together how to get there.
Right.
Yeah.
Yes.
Both materials design and equipment design.
Right. But the machine shop really had an interesting part there, because with the elements you used in the strong focusing, you had 4 rods essentially in a quad pattern, except that when you wrote down the equations and everything, it became obvious that you really, instead of having round surfaces, you wanted hyperbolic surfaces. And I went down and talked to Buddy, the head of the machine shop, and said, "Is there any way you could approximate this?" And he says, "Oh, we can make it exactly."
Wow.
And so he had figured out that if you, with a milling machine, put the tool off center and spun it around and ran the rod through that spinning arrangement, the surface that came out was a perfect hyperbola. So I didn't have to make any approximations. I could use the exact equations.
Let's talk about the actual construction of the Van de Graaff accelerator. Where did it come from and how was it made?
Well, the Van de Graaff was a WPA project, actually built a year or 2 before I was born. And it was going to be a new marvelous thing because they were going to build this high pressure container, and the higher you can get the pressure, the better insulating the air is and the higher the voltage can be. So it was going to be a very high tech sort of thing. And the pressure tank was rated for 150 psi, which meant that the walls were 2 inches thick steel and plates which had to have perfect welds. And this was the big deal with the WPA. They kept welders busy for quite a while getting perfect welds all the way up, and then since the end caps were bent in 2 directions, they only needed to be 1.5 inches thick. There was never any problem with that. They worked the way it was supposed to, and the standard operating pressure was between 90 and 100 psi. We had a full-time electrical engineer keeping the machine and all its electronics working. We had the support of the machine shop, the support of the glass blowing shop, the support of the electronics shop. There were 4 graduate students working in this department, taking shifts. We were not only doing our thesis work, but we were getting paid for maintaining the Van de Graaff for other people too. And so this was a team effort of at least 6 people, plus the shops.